Part 2, Project Earth. There's a concept in electrical engineering called the signal-to-noise ratio, which has to do with the ratio of a signal power to a noise power which corrupts the signal. It's like listening to music on your radio in a car, which is receiving a great deal of interference, and the music is becoming clouded and distorted. I think this is a great metaphor for our current social practices. The signal being the foundational aspects of importance and relevance to a given field, with the noise being the outdated, traditionalized, inefficient methods which cloud, confuse, delay, and distort our intents and abilities. So, I want everyone to forget pretty much everything I've just talked about and take a massive step back and consider a very simple thought exercise that I want to walk through in regard to how we conduct our operations on this planet. Let's assume for a moment that we are interstellar travelers originating from Earth as it is known today. And in our journey, we stumble upon, amazingly enough, an exact replica of our planet. The only difference between the current state of this new planet versus our own is that there are no human beings. Human evolution has not occurred. Hence, there's no establishment orders, no social arrogances, no money, of course, nothing to limit our possibility. Given the advanced scientific knowledge we have today, how would we go about redesigning our social infrastructure from the ground up, with the goal to create nothing less than the most efficient, conscientious, and sustainable society as possible? So, what is the first step? A full survey of Earth's natural resources would make sense, correct? I think it would be illogical to begin any other way. We must first understand the full range and capacity of the earthly components in order to derive inference as to our capabilities. Natural resources come in many classifications, such as biotic, meaning those obtained from the biosphere, such as forest, maritime organisms, and mineral fuels. And then there's abiotic, such as arable land, water, gold, iron ore, and other such raw materials. There are many natural resources to be considered, of course, but for the sake of simplicity, we're going to consider just one area, and this will serve as the prototype for all the others, and this area is energy. Energy is the fuel of society, I think most people would agree. Energy appears to be the lowest common denominator of modern civilization, and it has been the basic facilitator of progress and the expansions of our standards of living. So I think it's a good place to begin. Okay, so what do? We simply scan the Earth and analyze it, listing all relevant energy locations and potentials. Of course, the potentials, to clarify a little bit, is always going to be based on the current state of technology for harnessing. For example, solar energy today has a dramatic potential, but it is still greatly underutilized as the technology has been inefficient so far. But with the advent of nanotechnology, we are seeing a possible exponential increase in this potential. So it's contingent upon the quality of our methods, is my point. Also, I don't want to spend much time on the issue of nanotechnology, but if you research these trends as applied to solar radiation harnessing, it becomes clear that solar energy alone in time could power the entire world 1,000 times over. Unfortunately, you're not going to see this anytime soon. Why? Because it's too efficient for the market system. And the absorption process would take many, many years if seriously pursued. So, back to our original thought exercise. Once we have this raw data of energy sources, we need to rate each source based on its renewability, pollution output, and everything that factors in to decide the degree of sustainability. Those sources that have the most negative retroactions are given the least priority in utilization, of course. And by the way, this is an arbitrary chart. Don't take it too seriously, obviously. For example, fossil fuels are mostly non-renewable and can pollute the environment. Given the tremendous power of geothermal, wave, wind, and solar combined, I would say that there is absolutely no reason to even bother with fossil fuels at all. And to clarify this very quickly, I would like to run down these renewable medians. According to a 2005 Stanford University study, if 20% of the known potential of wind energy was harnessed, it would power all the world's needs. We already mentioned solar energy. The radiation hitting the Earth's surface is about 10,000 times the planet's usage, in fact. This issue comes down to technology, nanotechnology as we denoted. Lesser known is tidal power. As a regional example, in a recent study it has been found that 34% of all of the United Kingdom's energy could come from tidal power alone. But more effectively, as far as the ocean, is wave power, which has been found to have a global potential of 80,000 terawatt hours a year, meaning 50% of the entire planet's energy usage could come from tidal power alone. However, most effectively is geothermal energy, which, according to a recent MIT analysis, contains enough energy to meet the world's needs for the next 4,000 years. In other words, energy is nothing but abundant on this planet, and don't let anyone tell you otherwise. So, back to our exercise. Once this data is established, we compare the potentials to consumption and adjust accordingly. Fortunately, as we've just analyzed, we do have more than enough energy to meet our needs, so we can eliminate the least efficient sources, such as oil and everything else. And there we have it. We have our pool of supportive energy resources to utilize. Okay, step 3, distribution and monitoring. Energy distribution would be logically formulated based on technological possibility and proximity to sources. In other words, if we have wind energy utilized in Asia, we're not going to deliver that energy to Latin America. So distribution parameters would be self-evident based on the current state of distribution technology and proximity practicality. Likewise, active resource monitoring, done through Earth sensors and computers, would allow for a constant awareness of the rate of use, the rate of depletion, the rate of renewal, and any other parameter relevant to know, in order to maintain, of course, a balanced load. If the scarcity of any resource is going to occur, we can forecast this in advance through trend analysis, and proper action can be taken to adjust accordingly. This idea is nothing new. It's used every day in our lives in detached ways, such as the ink level notification on your personal printer connected to your home computer. Okay, let's review. What do we have so far? We have the locations of our energy resources. We have the output potentials and distribution qualifiers, which are based on strategic use, technological harnessing, and proximity. And finally, we have a system of active resource monitoring, which reports the state of energy supply, rates of usage, and any other relevant trends. In other words, we've created a system, a systems approach to energy management on the planet. The system is comprised of real-time data and statistics. The process of unfolding is based not on a person or group's opinion, not on the whims of a corporation or government, but on natural law and reason. In other words, once we establish the interest and goal that survival and hence sustainability is our goal as a species, which I hope everybody in this room agrees, then each parameter to consider in regard to resource management becomes completely self-evident. It is called arriving at decisions as opposed to making them, which is a subjective act based on incomplete information and very often cultural biases. The planet is a holistic system with resources all over it. Therefore, the efficiency of human society can only come from an integrated systems approach to the management of those resources and hence social processes. The planet demands it, if you will. The only government that exists is planetary operations, is natural law. It is inherently negligent, illogical, and irresponsible to function in a detached manner. We require a holistic system. Okay, using this energy model as our procedural example, this systems approach can be applied to every other earthly resource and quantifier. We survey, find potential, qualify for negative retroactions, and apply modern technology to harness, distribute, and monitor in the most logically advanced, holistic way possible. Naturally, a computer database management program would be the logical method to navigate these issues, where all the attributes we have discussed are fed in with strategic computation applied. And since the goal is holistic maximum efficiency, the automation of adjustments also becomes very simple. For example, let's say we have 2 geothermal power plants in the same region, each outputting in tandem the required amount of energy for that region. One day there's a problem, and the output of one plant drops by 30%. This would be seen by the monitoring system, and the other power plant's output would be automatically adjusted by 30%. It is reactive, just like the nervous system in your body, automatic. No reason to vote for it, no reason to debate it in Congress. It's automatic because it's self-evident.